In today's lesson, we are going to continue our intro to limits and looking further into estimating limit values from graphs. So the first part is, what is a one-sided limit? So in the last video, we were looking at a limit as, a function approaches an x value from both sides. And you can also look at it as just one side at a time. And we just have to add a little small detail into the notation. So I'm going to look at left side notation versus right side notation. So left-sided limit looks like this. It's the limit of f of x as x approaches a value a from the left. So it's like this little negative sign, kind of showing it's from the left. And then from the right side, you can probably guess what it's going to look like. The limit of f of x as x approaches a value a from the right. So you can have, looking at just the left-sided limit, or you could look at just the right-sided limit, or if you want to look at the limit of f of x as x approaches a, so not from the left specifically or from the right specifically. So if you want just at that value, what has to be true is that the left side has to equal the right side. So a left-sided limit could be different than the right-sided limit, but the limit at that value is only exists if the left side and the right side are equal. So let's look at these two graphs. First one, y equals 1 over x squared, looks like this. So what is the limit of the function as x approaches 0 from the left? So from the left, I'm getting closer to 0. It is approaching not a specific value, but it's approaching infinity. And then now the limit as x approaches 0 from the right. Okay, I'm approaching it from the right. Zoom up. Hey, that also approaches infinity. So because the left-sided limit and the right-sided limit are equal, the limit at that value as x approaches 0 is also positive infinity. Just a little side note, this is somewhat of a debated topic. Some say that it does not exist, that these do not exist because infinity is not a numerical value, but more of a concept. But know that infinity is what I'll use, and this is definitely accepted. All right, let's look at the other one. So just 1 over x. As the limit of 1 over x approaches 0 from the left, approaching 0, it's going to approach negative infinity. From the right, as I'm approaching 0, hey, well, that is going to approach positive infinity. And since the left side does not equal the right side, the limit as x approaches 0, this one does not exist. Now let's look at this piecewise function graph, and we're going to look at different limits. So we'll just call this f of x. So the limit of f of x as x approaches -2 from the left. So left, we're approaching -2. So from the left, we're approaching 1. Okay, so what is the limit of f of x as x approaches -2 from the right? Okay, so from the right, this approaches -2. So what is the limit of f of x as x approaches just -2. So because I'm approaching different values at -2, this limit does not exist. All right, let's do 3 more. I'm gonna write them down. Why don't you pause the video and then try them on your own. All right, so you should get, from the left it's approaching 1, from the right it's approaching 1, therefore as it's approaching 1, it equals 1. And now for our last example, I'm going to give you a bunch of scenarios and you're going to sketch a graph. So let's start with, I'm going to give you, we're going to graph function h. So let's say h of 2 equals 3. That's just function notation. That's a function value that at 2, I have the value 3. All right, so let's say I have the limit of h of x as x approaches 2 from the left. Let's say that is 5. So here's 2. We're approaching 2 from the left, and it's approaching 5. So I'm going to do open circle here. From the left, I'm just going to kind of sketch a line. So I know that from the left, I'm going towards 5. All right, let's look at the limit as x approaches 2 from the right is 3. Okay, so we're approaching 2 from the right, and that is 3. So I'm just going to make a little line coming this way. All right, so now the limit as x approaches -4 equals -1. So as I'm approaching -4, it equals -1. So that means it has to approach from both sides. So -4, -1, I'm just going to do an open circle here. I know has to approach from both sides. Let's say that f of -4 is undefined. F of -4, okay, so I'm going to leave that as an open circle. And then another little side note, h of x is increasing only on the interval from -4 to +2. So from -4 to 2, it is increasing, and it is not increasing anywhere else on this graph. So this can continue decreasing, and then this also decreasing. So there is a sketch of a graph that meets all of this criteria. So there is your second lesson on limits. Good luck when you work on the assignment.